Interest is payment for the use of money. And interest is paid when money is either loaned or when it's borrowed. For example, suppose I have a savings account at a bank and I deposit money into the savings account. Well, the bank is actually using my money in that situation. So the bank pays me a certain amount of money every month for that use, and that money is called interest. Now, on the other hand, if I borrow money from the bank, I want to buy a car, for example, or make some home improvements or something, then I'm using the bank's money, and I have to pay the amount of money I borrowed back to them, but I also have to pay them a little bit of interest for the use of that money. Now, the amount of interest is calculated according to the amount of money borrowed, which is called the principal, the interest rate, which is a percent, and it's some percent of the principal. You see, it's a percent based upon the amount of money borrowed. And time. You see how long. The longer you borrow the money for, the more the interest. It would make sense. All right, so the situation is that interest is calculated as principal, the amount of money borrowed, times rate times time. Now, the rate is an interest rate, and it's in the form of a percent. There is an agreement between rate and time, or a relationship, I should say. The rate of interest is usually some percent per year. And when that is the case, then the time is expressed in years. If the rate is a rate per month, then the time would be expressed in months. So we have a formula then. Interest is principal times rate times time. Let's use the formula in a couple of problems. Let's calculate the interest when $500 is borrowed at 8% interest for 2 years. So we write the formula. And be sure to always write the formula. This is kind of an important habit to get into. We're going to be facing formulas from time to time in this course, and the way that we use formulas should be the same no matter what the formula is. And that way is to write the formula in the first step, and in the second step, replace letters with numbers. And then in the third step, begin to make calculations. That's just a good habit to get into. All right, so we write the formula. Now we replace letters with numbers. We're trying to find the interest. P stands for principal, the amount of money borrowed. That's the $500 from above. R is the interest rate, and that's in the form of a percent. It's 8%, and I'll write it as a decimal. And the time is 2 years. Now, we're assuming this agreement between interest rate and time. That is, this is an annual interest rate, a yearly interest rate, and we have years for the amount of time. That's kind of an important consideration. Multiplying on the right, we find 80 to be the result of this multiplication, and so the amount of interest is $80. Here's another one. $300 is invested at 6%. Now let's assume that this is an annual interest rate, but the money is only borrowed for 4 months. Let's see what we do about that. We start the same way that we did before. Interest is principal times rate times time. The interest then is, well, let's see, $300 times an interest rate of 6%. And this is an annual interest rate, so time has to be written in years. Now, 4 months is what part of a year? That's really what we're asking ourselves. And we can write this as 4/12 because there are 12 months in a whole year, and we're talking about 4 of those months. So 4/12 of a year is what this is all about. Now, if this amount of time was in days, if this was, let's say 60 days or something like that, then the portion of a year would be 60 over 365. You see, the number of days in a year is 365. So we have to make a fraction here when it's parts of years. And that's really no big deal. We can write this as a fraction, by the way. We could reduce the fraction. We could write this as a decimal. All of those would be just fine. But the important thing is to write the time in terms of years if this interest rate is an annual interest rate. All right, multiplying here, we would find this to be $6. Now, we might think about if a person is making an investment for 4 months at this interest rate and has earned $6, how much money does the person have? Well, the person has the initial investment of $300, plus that person has the $6 that investment has earned in interest. So $6 plus 300, the person has now, the value of the investment, the total value of the investment is now $306. Now, that total value of the investment is called maturity value. And this is just a fancy word for the principal along with all of the accumulated interest. Maturity value. So it's just principal plus interest gives maturity value. And in the problem that we were just looking at, the principal $300, the interest $6. So $306 is the maturity value of the investment. Interest is involved when credit cards are used. Credit card companies charge a certain amount of interest every month on unpaid balances. Now, let's talk about unpaid balances. Suppose that I charge $500 in a month, and I make a payment to the credit card company. I get a statement that says that I owe that amount of money, that I owe $500. And let's say that I pay only $300. Well, my unpaid balance then is $200. And in the next business cycle, the next monthly cycle, I'm going to pay interest on that money that I am borrowing from the credit card company. So that $200 is the unpaid balance. Now, credit card companies charge interest monthly because they send out statements every month. So this is a monthly interest rate. And let's make a calculation of finance charges, which is nothing but an interest that is charged to customers on unpaid balances. Let's see what the problem looks like. All right, the problem involves finance charges, and it says a credit card company charges 1.5% per month on the unpaid balance of charges on a credit card. What is the finance charge in a month when a customer has an unpaid balance of $254? Well, we can find that finance charge. It's just an interest, and we can use our formula. And the amount of interest is, let's see, the unpaid balance is $254. That's the principal in the formula. The interest rate is 1.5%. As a decimal. Now think about changing it to a decimal, and let's be careful about that. Let's move up here and kind of look at it a little bit. If we're changing this into a decimal, then we're sliding this decimal point 2 places to the left. So we'll need a 0 as a placeholder, so it's going to be 0.015. So 0.015, and we'll write a 0 to the left of the decimal point as well. Now the time here, since this interest rate is a rate per month, we're expressing time in months, and we're only talking about a 1 month period of time here. So 1. And now multiplying, we find that the amount of the finance charge, the interest you see, is $3.81. In all of our previous examples involving interest, the interest was calculated on the original principal. And in that circumstance, it's called simple interest. Well, simple interest isn't always the way that interest is calculated in real life. It turns out that for many investments and for the borrowing of money, that interest is actually calculated perhaps monthly, and the investment or the loan might be for a very long period of time. And here's how that situation works. We have to think about, well, let's see, I've borrowed some money and I want to borrow the money for a long time, but the bank is going to calculate interest every month. So here's what they're going to do. They're going to calculate the interest that has accrued for the first month. And at the end of that first month, they're going to take my principal and add the interest that I've accrued. And now, at the end of that first month, I've got interest and principal. And during the second month, the interest is calculated for the principal and the interest from the first month. Whoa, it sounds complicated. It is a little bit, but it's not too awful bad. We're going to look at a circumstance right here, an example of this, and it's called compounding interest. Now let's just look directly at the example without explaining further. How much interest is earned if $500 is invested for 5 years at an annual interest rate of 6% compounded annually? Now, compounding annually means that the interest is accumulating or is figured out every year annually. Now, the compounding of interest may occur monthly, it may occur daily, it could occur in a lot of different time frames. But here in this example, it's compounded annually. So let me show you what happens in this compounding situation. Now, I'm going to warn you, it's going to look a little complicated at first, but we're going to have a chart to help us with the calculation at the end of this. But we need to know how this works. In the first year, here's how we figure out the interest. It's the way that we figure simple interest from the beginning, from our other examples. In year one, the interest is figured using the formula, $500 for the principal, 6% interest 1 year. So $30 is the amount of interest. Now, at the end of 1 year, how much money is in the investment? Well, it's the $500 plus the $30 in interest that was earned. So $530 is the new principal. Now, that's the principal that we're going to use to make the calculation of interest in the second year. So let's go over here and do that. Year two. We have same formula, but the principal now is $530 during year two. The interest rate is the same and the time is the same. The amount of interest during the second year that's earned during the second year is $31.80. That is to be added to the principal here to find out the new principal at the end of the second year. So it's $530 plus $31.80 or $561.80. That's the principal in the investment. That's a total amount in the investment at the end of the second year. And this is the amount that's earning interest during the third year. So for the third year, here we go with year three. Interest is principal times rate times time. Here's our new principal. Same rate, same time. And our interest, the amount of interest earned during that third year, $33.71. We take this amount, add it to that principal, and we have a new principal at the end of year three. And that principal is being used to earn interest during year four. So we have $595.51. The amount of interest, therefore, earned in year four, $35.73. Now we add the $595.51 to the $35.73 interest earned, and we have the new principal for year five. Here we go with that. Year five, the interest formula, $631.24 times the 6% times 1 year. The interest earned during that year, $37.87. We add these together to find that the total amount in our investment at the end of this 5-year period is $669.11. Now, the problem was actually asking for the amount of interest that was earned in this investment. Now, this is principal and interest that's given right here. So if we want just the interest, then we have to take this total amount in the account and take away the original investment, the original principal of $500. So let's do that over here. $669.11 minus the $500 of total of original investment gives us an interest of $169.11 of interest earned during that period. Now, if we had made this calculation according to simple interest, the amount of simple interest could have been found by interest is principal times rate times time, the principal $500, the rate 6%, and the time 5 years. And if you do that calculation, you find out that the amount of interest would be $150 exactly. And so in this compounding business, a bit more interest has been earned. Now, I mentioned that compounding can occur monthly, it can occur quarterly, it can occur annually, it can occur daily. There are a lot of different ways to calculate this compounding of interest. But think about a situation of perhaps a home mortgage where money is borrowed from a bank to buy a home, and the interest on that loan is compounded every month. So we've got this calculation to make every single month, you see. And we have payments that are made and interest that's charged, and it becomes a relatively complicated situation if we're doing it by hand. There are charts to help us, though. Now, I'm going to show you one that is very similar to the one that's in your textbook. And the chart will allow us to identify a number which we can multiply times the original principal and find out the amount of principal and interest, that is, the amount in the investment, at the end of a particular period of time. Let's take a look. Notice that it has numbers at the top that represent the interest rates. Also, you'll see the years on the left-hand column and the interest rates at the top. Now, notice that we're in the segment marked compounding, compounded annually. And there's another segment marked compounded semi-annually, compounded quarterly, and so on, all the way down to compounded daily. But let's concentrate where we are with our problem. Now, the way you read this and use this chart is you look along the top row at the percent, the interest rate that you are interested in, and we're talking about 6%. You read down at the number of years. We're interested in 5 years. So the crossing of the row and column of those two would be the number 1.33823. And if you take that amount, that number, and multiply times our principal that we started with of $500, 500 times 1.33823, we get the amount in the bank at the end of the 5-year period. We get the amount that we calculated on the board.